Okay, please observe this question. I have framed this in order to recall all the concepts and in a more better way. Okay, so till now we have read about the Faraday's law of electromagnetic induction, Lenz's law, MMF, and the polarity of magnet because of the current flowing in the conductors. Okay, now please observe what is saying in this question. A coil of 2000 turns surrounds a flux of 5 milliweber produced by a permanent magnet as shown in figure. The magnet is suddenly withdrawn, causing flux inside the core to uniformly drops to 2 milliwebers in 1/10 of a second. Find the magnitude and the polarity of induced EMF across the coil. Okay. So what they are explaining, please see. We have 2000 turns which is wounded over some iron core, and if the magnet is placed in position 1, then the total flux inside the core is found to be 5 milliweber. I am taking an assumption that the flux is uniform and that is equals to 5 milliwebers. If suddenly magnet is withdrawn from position 1 to position 2 in 1/10 of a second, by withdrawing this from position 1 to position 2 in 1/10 of a second, the flux, as the reluctance increases because of the increase in the air gap from the magnet to the core, the flux in the core drops down. I am considering that flux is uniformly dropped down to 2 milliweber. So, is there any change in flux? Yes, sir. Previously the flux in the core is 5 milliweber and now the flux in the core is 2 milliweber. So, there will be a change in flux, and that change in flux is with respect to time in 1/10 of a second. The total change in flux is in 1/10 of a second. So, sir, there will be d phi by dt. All the conductors are wounded, the conductor is wounded over the core, and in the core the flux is changing. So, definitely the flux linking the coil changes with time. Whenever flux linking the coil changes with time, there will be a induced EMF across the coil as per the Faraday's law of electromagnetic induction. So, one can say, sir, there will be induced EMF across this conductor, that is 2000 turns, and that induced EMF is as per the Faraday's law of electromagnetic induction. You can say, sir, plus minus n d phi by dt. So, the total number of turns are 2000. The total change in flux is from 5 milliweber to 2 milliweber in 1/10 of second. So, because this is in milliweber, we must have to write Weber. So, you can say, sir, we can represent this plus minus 2000 into 3 into 10 to the power of minus 3. This is to convert milliweber to Weber by 1 by 10. So, when you solve it, this will be plus minus 60 volts. Okay, sir. So, if I am going to shift this magnet from position 1 to position 2 in 1/10 of a second, there will be a change in flux linking the coil. So, there must be an induced EMF as per the Faraday's law of electromagnetic induction, and the magnitude of induced EMF is equals to 60 volts, and the magnitude of induced EMF is equals to 60 volts. So, one can say, sir, whether we have to take plus 60 volts or minus 60 volts. Now, it depends upon the Lenz's law, where this plus and minus sign is due to the Lenz's law. So, what Lenz's law explain? Please focus here. This plus and minus sign is due to the Lenz's law. So, what Lenz's law explains us? According to Lenz's law, the polarity of induced EMF is such that if it allowed to cause a current, then current so produced must oppose the cause. So, please observe, what is the cause of production of this induced EMF? The shifting of magnet from position 1 to position 2. The polarity of induced EMF must be such that if it allowed to cause a current, then current so produced must oppose this shifting of magnet from position 1 to position 2. We all know that if the current flows through the wire wounded over the core, then core will act as a magnet. So, what must be the polarity of this magnet so that it opposes the shifting of this magnet from position 1 to position 2? One can say, sir, this must be south and this must be north. If the current flows into the wire, then current must produces the flux in such a way that this terminal will act as a south. Because if it will act as a south, then it opposes the shifting of magnet from position 1 to position 2. Okay, we all know that the right hand grip rule. From the right hand grip rule, we know that if the direction of current is grip, is represented by the grip, then thumb will represent the direction of flux. So, one can say, sir, in order to this to be the north, current must flow in this fashion. So, one can say, sir, current can flow in this fashion only in order to oppose the cause. So, the polarity of induced EMF, I am again saying, the polarity of induced EMF across AB is such that if it allowed to cause a current in the coil, then that current in the coil which makes a magnet, and that magnet must be such that it opposes the cause, and the cause is shifting of the magnet, shifting of this permanent magnet from position 1 to position 2. So, in order to oppose the cause, this must be south. So, definitely it will attract and it opposes to force the magnet from position 1 to position 2. Now, the polarity of induced EMF, who decide the polarity of induced EMF? Now, according to the Lenz's law, you can take it as plus or minus. Whether you are considering this EMF that draws current into the wire, or whether you are observing the polarity of induced EMF from the load. Always remember, the current flows through the winding only when the winding will have complete circuit. And for the winding to be complete circuit, we must have to apply the load. Okay. So, if we are going to apply the load, then always induced EMF will act as a source for the load. So, from the load side, if you mark the polarity, then load observes that current comes from this terminal and returning back to this terminal. So, for load, this A is acting as a plus and B is acting as a minus. Is it okay? Always induced EMF is a source for the load. Always induced EMF is a source for the load. Please observe. Let us suppose I have two electrical components, this and this one. So, if I ask you which one is a load and which one is a source, then what you say? If I ask you which component out of these two is a load and which component out of these two is a source, if the current is flowing in this fashion, you can say, sir, from the positive terminal, if the current is going towards the load, this must be the load component and this must be acting as a source. Again observe, let us suppose we have two electrical components and the components are represented in this fashion. If the current direction is represented in this fashion, now which one is a source and which one is a load? One can say, sir, because of the positive polarity, current is coming. So, it means this appears to be the battery to be charging. So, you can say this to be the load now and this to be the source now. So, you can say, sir, from the direction of current we can find the source and load. अगर आप यहाँ पे देखें, so यहाँ पे देखिए, the polarity of induced EMF must be such that if it allowed to cause a current in the winding, then that current opposes the cause. This suggests us the direction of current is this. Now, which terminal is positive and which terminal is negative, that always observed by the load, because for load induced EMF is a source. So, induced EMF polarity is marked from the load side. From the load side, this terminal A acting as a positive, as the load observed current is coming from this side and current is going to this side. Is it okay? So, one can say, sir, the polarity of induced EMF is this. If you mark the polarity in this fashion, you can say E is equals to 60 volts. It means, if you mark the polarity of induced EMF from the load side, then always you can take E is equals to plus ND phi by dt. One can also say, sir, if we just observe this as a voltage source and this voltage source is causing current irrespective of the load, then one can say, sir, this is appearing to be going inside and this is appearing to be coming outside. One may mark in this way, this is positive and this is negative. But the polarity of induced EMF marked in this way, that B is positive and A is negative, is wrong, because that is not the induced EMF creating current in the winding. The induced EMF always is supplying current to the load, and that is why if you mark this as a positive and this as a negative, you have to represent E is equals to minus 60 volts. So both the things are same. One can say A is positive, E is plus 60 volts. One can say A is negative, E is minus 60 volts. So both are correct. Both are correct. Is it okay? So plus or minus sign is totally depends upon which terminal we are taking positive. In our discussion, in my discussion, I always keep the induced EMF polarity as plus ND phi by dt, because I always mark the polarity of induced EMF from the load side, because for load induced EMF is acting as a source. Okay, so always mark the polarity of induced EMF from the load side. So you can say, sir, from the load side, agar induced EMF dekha jaye, so induced EMF EAB can be represented as plus 60 volts if A is positive, and B is negative. Or one can say, sir, EAB is equals to minus 60 volts if he considered A is negative and B is positive. Both the things are same. So this is the basic concept behind plus and minus ND phi by dt. Because some can understand in this way that induced EMF is creating current into the winding, and some may observe this induced EMF as a source for the load which is applied onto the winding. And this must be in this fashion. This must be in this fashion. Now please observe. If I mark the polarity in the correct way, I can say, sir, the induced EMF is equals to plus 60 volts and the current is flowing in this fashion. In case if I increase the load means now I am going to connect the load in parallel, because electrical loads are always connected in parallel. So if I connect the load in parallel, for the same voltage, if I connect the load in parallel, then parallel impedance will down. If two equal impedances are connected in parallel, then equivalent impedance will become Z by 2. It means if I connect the load in parallels, then overall impedance down. For the same voltage source, if impedance down, current increases. So that is why whenever in electrical circuits we say that load is increasing, it means the current is increasing. So if the load is increasing, then current increases. With the increase in current, these magnetic potentials will become more stronger. It means now this electromagnet will act more strong magnet. If this electromagnet act as more stronger magnet, then it will not allow to shift the position from 1 to 2. Now ultimately the energy given by my side by shifting this from position 1 to position 2 is going to be delivered on this side. If more electrical load is required, it means more energy is required at the output side, then it will be difficult for me to shift from position 1 to position 2. So ultimately, whatever energy I given, that is going to be transferred there. Are you satisfied with my opinion? I am hoping so. So whenever there will be a d phi by dt, there will be an induced EMF across the coil, and the induced EMF in the coil must be in such a way that if it allowed to cause a current, then current so produced must oppose the cause. This is the basic phenomena of transferring energy from one side to another side. All generator, DC synchronous induction, all motors, DC synchronous induction, transformer, all works on the same principle. Is it okay? So Now I am hoping that this numerical will give you a quite effective information from the past lecture. Okay. Now you are able to understand what is MMF, how the MMF is going to induce onto the coil, what is the polarity of induced EMF onto the coil. Okay. Now I am going to show you the polarity of induced EMF as per the Lenz's law under different conditions. Okay. Now let us consider an ideal core on which wires are wounded. Let us consider an ideal core. Let us consider an ideal core on which wires are wounded. On which wires are wounded. Let it be the wires are wounded in this fashion. Okay. As I am saying an ideal core, so whatever I want I can take an assumption. Okay. So I am just taking an ideal core and let us suppose this on this ideal core n number of turns are wounded in this fashion. Okay. So I am considering that this to be an ideal core. So without any magnetizing current, flux establishes in the core. Without any excitation, let us suppose this core will have magnetic energy. Not only that, this core will have magnetic energy variable. You can say, sir, magnetic energy in the core is okay, you can use a permanent magnet. But I am not saying just a permanent magnet, I am saying this is an ideal core and let us suppose this core will have magnetic energy and that magnetic energy is changing that magnet is changing its polarity as per the function of time. So let us suppose we have an ideal core and in this ideal core I am considering there will be a flux. Without any excitation, the flux exists in the core and that flux is varying with respect to time. Let it be in a sinusoidal fashion. So you can say, sir, there will be flux inside the core which varies with respect to time. Okay, what does it mean? Let us suppose the entire flux cycle is of 20 milliseconds. So it means that frequency is 1 by 20 milliseconds, that is you can say 50 hertz. So I am considering that this core itself has one flux and that flux is varying with respect to time. With respect to time means when you go with a 0 time instant, then flux is 0. After 5 milliseconds from this instant, you found that flux will be maximum. After 5 milliseconds, you found that flux will be maximum in one direction. Let us suppose in this direction. Flux will be maximum in this direction. After 10 milliseconds, again the flux is 0. After 10 milliseconds, again the flux is 0. And after 15 milliseconds, again the flux is in the negative maximum direction. Okay. So it means negative maximum means now the flux is in the downward direction. So let us suppose for an instantaneous flux, this flux is changing with respect to time. Let us suppose an instantaneous flux. Instantaneous flux means the flux at one instant. The flux is at one instant is phi and the direction of flux is in this direction. Okay. So we have an ideal core and this ideal core contains a flux and that flux is varying with respect to time. This is my assumption because this is an ideal core. So when I am saying ideal core, then I can assume anything whatever I want. So we have a core and that core is a magnet and that magnet is changing its polarity with respect to time. I am saying this such type of material is not available. You can say permanent magnet is available, but how we can say that magnet is available and that magnet is changing with respect to time? The polarity of that magnet is changing with respect to time. No such material is available. This is just an ideal case I am taking. So let us suppose we have an ideal core and that ideal core contains a flux and that flux changes with respect to time. At one instant t is equals to t naught, that is for a 50 hertz frequency flux you can say after 5 milliseconds. So at t is equals to t naught, let the instantaneous flux is this. I want to know about the polarity of induced EMF at terminal AB. Polarity of induced EMF at terminal AB. This is an ideal core. This ideal core contains a flux which varies with respect to time. So definitely the flux in the core changes with respect to time. Since the wire is wounded over the core, so you can say the flux linking the wire changes with respect to time. Whenever the flux linking the wire changes with respect to time, there will be an induced EMF across the coil, and that induced EMF is given by d phi by dt. I am taking plus and d phi by dt. It means we mark the polarity of induced EMF by considering that induced EMF is a source, and we mark the polarity from the load side. So the polarity of induced EMF must be such that which opposes the cause. At this particular instant, what must be the polarity of induced EMF so that it will opposes this flux? One can say, sir, the polarity of induced EMF as per the Lenz's law must be in such a way that if it allowed to cause a current, then current so produced must oppose the flux. So for this instant, this instantaneous flux must be opposed by the current caused in the wire. So one can say, sir, if the polarity of induced EMF must be such that if it allowed to cause a current, then current so produced must oppose the flux. In order to oppose the flux, current must flows in this way. If the current will flows in this fashion, so you can say N into I will create an MMF, and that will create a flux which opposes this flux. Okay, so the direction of current must be in such a way that if it allowed to cause a current, then current so produced must oppose the cause. Let us suppose the current is flowing in this fashion. If the current flows in this fashion, then it will create a flux phi 2 which opposes this flux. Is it okay? So the current, the polarity of induced EMF must be in such a way that if it allowed to cause a current in the winding, then the current flows in the winding is always in such a way that it will opposes the cause. So in order to oppose this flux, it will create the flux downward. So the polarity of induced EMF observed from the load side is, load observed that current is coming from this terminal and going to this terminal. So load mark the polarity of induced EMF as this as plus and this as minus. It will create a flux at this particular instant, it will create a flux. You can say at the same instant your flux phi 2 will be created which opposes the flux phi. As happens to position t is equals to t naught, the same thing is going to happen to all position. It means the polarity of induced EMF at every instant is such that if it allowed to cause a current, then current so produced must oppose the cause, and in order to oppose the cause, you can say, sir, as the flux polarity changes from this side to this side, the current direction changes from this side to this side, and induced EMF polarity changes from this plus minus to this plus minus. So as high as the frequency of flux, your frequency of induced EMF changes. Is it okay? So the polarity of induced EMF must be such that if it allowed to cause a current, then current so produced must oppose the cause. And this is the requirement also, because whatever magnetic energy is stored inside the core, that is taken from this load in an electrical format. So if the magnetic energy is taken in the format of electrical energy, definitely the magnetic energy is going to be lowering down. Not only at one instant, at all the instant. So you can say, sir, the polarity of induced EMF must be A as positive and B as negative. Again observe, let us suppose this is case 1, an ideal core. I am saying consider an ideal core for an instantaneous direction of flux shown, mark the polarity of induced EMF across AB. Okay. So again please observe, let us suppose we have a core. Let us suppose we have a core, and on this core wires are wounded in this fashion. Let us suppose we have a core and wires are wounded in this fashion, n number of turns are wounded in this fashion. Okay. So if this is an ideal core, it carries a flux and the direction of flux is changing with respect to time. It means the magnetic polarity of this core is changing with respect to time without any excitation. This is the material. Let us suppose this. ये material एक permanent magnet है. Let us suppose this material to be the permanent magnet and the polarity of this magnet is changes with respect to time. Okay. So, for an instant t is equals to t naught, let us suppose the instantaneous flux is this. For an instant t is equals to t naught, let us suppose the instantaneous flux is this. The polarity of induced EMF, the instantaneous polarity of induced EMF must be such that if it allowed to cause a current, then current so produced must oppose the cause. In order to oppose this flux, current must flows in the right hand grip. From the right hand grip rule, current must flows in such a fashion that it will opposes the cause. So, current must flow in such a fashion that it will create a flux that opposes this flux. So, from the right hand grip rule you can say current must flow in this fashion. If the current is flowing in this fashion, you can say, sir, load will mark the polarity of induced EMF, because for load induced EMF is a source. So, if you observe from the load side, the induced EMF is n d phi by dt again. But now please observe, if the when the load observes the current, load found that current is coming out from this port and going into this port. So, you can say load mark this as plus and this as minus. The same instant, same core, but the polarity of induced EMF in two things are different only because of the way of winding wound over the core. In one way, your core, the windings are wound in a clockwise fashion, while here the windings are wound in an anti-clockwise fashion. Again, as the flux changes with respect to time, this polarity of induced EMF changes with respect to time, and the polarity of and the frequency of induced EMF is same as the frequency of flux. Is it okay? Now again observe, you can say, sir, when the current flows in this fashion, it will create a flux, and that flux is in such a way that it will opposes the instantaneous flux. Whatever electrical energy drawn here, due to which magnetic energy must be lowered down at the same instant, and here we can observe phi 2, because of phi 2 this phi decreases to some lower value, and this must be the case. Now please observe, you can say, sir, we can find the polarity of induced EMF, as per the Lenz's law in both the case. Now again observe, case number 3rd. In the different books, it is represented in different fashions. So, I am trying to represent all the cases. Let it be case number 1. Case number 1. Let us suppose we have an iron core, this. In terms of transformers, this is also called as a window, and the wires are bounded over this core in this fashion. Wires are bounded on this core in this fashion. Please focus, the wires are bounded on this core in this fashion. Let it be N1 turns and let it be N2 turns. Again, I am considering the core to be ideal. If the core is ideal, and let us suppose the instantaneous flux in the core is phi. Let us suppose instantaneous flux in the core is a phi. If this will be the instantaneous flux, then magnetic line of forces opt this path, because magnetic line of forces always try to flow through the low reluctance path, and as I am saying the ideal core, it means all the magnetic line of forces are confined within the core. So, you can say, sir, magnetic line of forces are taking the path in this fashion at this particular instant at t is equals to a t naught instant. Let the flux is phi, and that flux is a taking path here in this fashion. Okay. So, the polarity of induced EMF E1 and E2 must be in such a way, the polarity of induced EMF E1 and E2 must be in such a way, if the induced EMF are allowed to cause a current, then current so produced must oppose the cause. Please tell me what will be the polarity of induced EMF here, so that if it allowed to cause a current, then that current will opposes the cause. As per the right hand grip rule, if the direction of current is represented by the curl, then the direction of flux is represented by the thumb. So, this must be the direction of current in order to oppose this flux. In order to oppose this flux, this must be the direction of current. Is it okay? So, the instantaneous polarity of the induced EMF can be marked in terms of current. Please observe. You can say, sir, load can observe this terminal as positive and load observe this terminal as negative. Again observe on this side. The same flux at the same instant will produces induced EMF here also. As this flux is changing with respect to time, so there will be a d phi by dt across the coil and there will be an induced EMF across both the coils. The same flux is responsible for the induced EMF across both the coils. Okay. So, the polarity of induced EMF, the polarity of this induced EMF must be in such a way that if it will allow to cause a current, then current so produced must oppose the cause. In order to oppose the cause, current must flows in such a way that it will opposes this flux. In order to oppose this flux, the current must produces the flux in the opposite direction. So, you can say the current must flow in this fashion in order to oppose the cause. And you can say, sir, we can experiences here that this terminal is going to be positive and this terminal is going to be negative. Now, it introduces the concept of dot. The same flux will produces the induced EMF in both the coil 1 and 2, and at the same instant t is equals to t naught, this terminal and this terminal is found to be of same polarity, so they are represented by the dots. So, they are represented by the dots. You can say, sir, why you have represented dot here? Why you are not representing dot at this position? Yes, you can also represent the dots at this position, because this is an instantaneous polarity and the polarity is changing at every half cycle. What this dot represent? This dot represent that both the dot indicated terminals are of same polarity at same instant. Both the dot terminals are of same polarity at same instant. Bas, this is just representing this. This is just representing that both the dots are representing same polarity at same instant. Is it okay? Because this is an instantaneous polarity. So, on every half cycle the polarity is going to be changed. Again observe case number 2. Let us suppose we have one ideal core, and on this ideal core wires are bounded in this fashion. Wires are bounded in this fashion. Now, please see, I have changed little bit. The coil 1 is wounded in the same fashion as previous. However, coil 2 is now wounded in the different fashion. Previously, the coil is wounded in a anti-clockwise manner, and now I am going to wound this wire in a clockwise fashion. Let us suppose this is an ideal core. So, I am saying in ideal core, it means it already contains a flux without any excitation, and that flux is changing with respect to time. Whenever there will be a flux changes with respect to time linking the coil, there will be an induced EMF across the coils. Let us suppose the flux in the core is this, instantaneous. Instantaneous means at one instant. At one instant let it be the flux, and this flux is taking path in this fashion as the core is assumed to be ideal. So, all the magnetic line of forces are remain within the core. Now, this flux is changes with respect to time. So, there will be an induced EMF. Let this induced EMF is E1 and induced EMF is E2. The polarity of induced EMF must be in such a way that if it allowed to cause a current, then current so produced must oppose the cause. By the right hand grip rule, if this will be the flux, then in order to oppose the cause, the current flowing in the wire must produces the flux in such a direction that will opposes this flux. So, the instantaneous polarity of the current, the instantaneous direction of the current in the wire must be in this way, right hand grip rule. If this will be the direction of current, then thumb will represent the direction of flux. So, you can say, sir, this must be the direction of current. Now, please observe, if this will be the direction of current, then one can say, sir, load found this terminal to be positive and this terminal to be negative. At the same instant, the same flux is linking this coil also. Since this flux is changing with respect to time, so there will be an induced EMF across this coil also. And the polarity of induced EMF here must be in such a way that if it allowed to cause a current, then current so produced must oppose the cause. In order to oppose the cause, current must flows in this fashion. So it will opposes this flux. One can say, sir, current is flowing in this fashion means, load observe that this terminal to be positive and this terminal to be negative. For the same flux, for the same instant, now what we found, this terminal and this terminal will have same polarity. So you can say, sir, these two terminals will have same instantaneous polarity. So you can represent a dot here, then you can represent dot here. The two dots are representing the same induced EMF polarity at the same instant. One can also say, sir, you can represent these two dots here and here also. No issue. Now please observe. You can say, sir, this terminal and this terminal is 0 degree displaced. However, this terminal and this terminal is 180 degree displaced, while this terminal and this terminal is 0 degree displaced. Is it okay? So, always remember that the dots are not representing positive or negative, dots are just representing that at the instantaneous, that for the same flux, instantaneous polarity on the two different coils wounded over a core will have same polarity, instantaneous same polarity. At every instant, when the flux changes in this fashion, this will become negative and this will become negative. These two will become positive. So both the dots will have same polarity and both without dots windings will have same polarity. Is it okay? Most of the time student just remember, try to conclude that whenever wire found to be overlapped in this fashion, then that one is taken as a positive or dot. Whenever wire is wounded over in this fashion, then that will taken as a positive. Whenever wire is over wounded in this fashion, that is taken as positive. Whenever wire is wounded in this fashion, that is taken as positive. No, this is not the conclusion. I am just saying the two terminals which have same polarity of induced EMF for the same flux are marked as a dot. Now please observe, in the third case it will elaborate you. Third case. Now see, let us suppose we have a ideal core, and on this ideal core we have a windings wounded. Let the windings are wounded in this fashion. Let the windings are wounded in this fashion. Okay. For this to be the instantaneous flux, mark the polarity of induced EMF E1 and E2. The polarity of induced EMF E1 must be in such a way that if it allowed to cause a current, then current so produced must oppose the cause. In order to oppose this flux, current must flows in this fashion. So one can say, sir, the direction of current can be marked in this way, or you can say, sir, the induced EMF polarity is always observed by the load. Load observed that the current is coming out from this and going into this. So load mark this induced EMF as positive and negative source. Instantaneous. This polarity is changing at every instant, as at every different time as this flux is changes with respect to time. Again, the polarity of induced EMF E2 here must be in such a way that if it allowed to cause a current, then current so produced must oppose this flux. In order to oppose this flux, current must flows in this way. Okay. So if the current is flowing in this fashion, you can say, sir, we can found the polarity of induced EMF to be this as positive and this as negative. So if I represent dot here, then where we have to represent dot in the other winding? You can say, sir, we must have to represent the dot here in the other winding. So dots are just representing the polarities. Never use the concept that the current is going into the dot. No, that is not the concept that current is always going into the dot. The concept is that the same flux will produces same polarity of two terminals. The two terminals of the two different windings of having same polarities are represented by dots. The dots will have same polarity at every instant, and the without dot terminals will have same polarity at every instant. One more, case number 4. Let us suppose we have a ideal core. When I am saying ideal core, it means it contains a flux and that flux is varying with respect to time. Let us suppose we have an ideal core, and on this ideal core I have bounded a winding in this fashion. If the wires are bounded in this fashion, then the polarity of induced EMF E1 and E2 are. Also mark the dot. For an instantaneous flux, this. If this will be the instantaneous flux, then you can say the polarity of induced EMF must be in such a way that if it allowed to cause a current, then current so produced must oppose the cause. So in order to oppose the cause, this must be plus and this must be minus. Don't flow the current by this polarity, because current always flow only when the load is connected, which means circuit is completed. So for the load, this induced EMF is acting as a source, and accordingly we have to mark the polarity. Then only we can use plus and d phi by dt. Otherwise, if you change the polarity, you have to take it as minus and d phi by dt. Is it okay? Now, what must be the polarity of induced EMF here? The polarity of induced EMF here is in this fashion. The current must be in such a way that it will opposes this flux. So in order to oppose this flux, current must be in this fashion. So you can say, sir, this must be the current. For this to be the direction of current, this is found to be positive and this is found to be negative by the load. You can say, sir, if the dot is represented here, then we must have to represent the dot here. So just don't say the dots are representing, that is overlapping the core from our side of view. No, the dots are just representing that two different windings having two different terminals of same polarity at every instant. Is it okay? So that is the concept of polarity of induced EMF as per the Lenz's law, and I have taken all the concept. If you go with P.S. Bhimra, you will found this one as the case. If you go with P.S. Bhimra, you will found this as an ideal case transformer, and they mark the polarity in this fashion. This is the case we found in Nagarath and Kothari, and this is the case you found in Pearson book. Okay, that is your Theodore Wilde. So all these concepts just try to elaborate. With all these cases, I just try to elaborate the polarity of induced EMF in different winding sections at the same instant. So if we have the polarity of induced EMF on primary side, then just by knowing the dot, we know the polarity of induced EMF onto the secondary side. The dot marking is just in order to know that the two different windings will have the two different windings out of 4 terminals, which 2 terminals are of same polarity.